In question 19, we're given the following table here, and we're asked to work out which row in this table shows the response of the iris to reducing levels of light. Okay, so we have to consider the effect of reducing levels of light on the radial muscles, the circular muscles, and the pupils. So, going into the BMAT, you need to be familiar with these sets of muscles and the general response of the pupils to light. So let's familiarise ourselves with these muscles and the pupils. So in our eye, we'll have this region here, represented in green, which is the iris, surrounding the pupil. Now within the iris, we'll have the circular muscles, which encircle the pupil, and the radial muscles, which are a bit more peripheral. And those similarly change in response to light, to modify the size of the pupil, which is the entry point of light, which then reaches the back of the eye in the retina, which allows us to form images. So, when there's bright light, what the iris does is change such that the pupil is constricted and less light can enter because there is so much light going in that it needs to be regulated. However, in the case of low light, which is what we're being asked about in this question, reducing levels of light, the pupil must dilate to allow as much light in as possible so that the maximal amount of surroundings can be gleaned from reduced levels of light. So how do the muscles respond? So we've talked about how the pupils constrict and dilate respectively, but the muscles, by contrast, do different things. So I've modelled what the muscles do here, and we'll talk through it. So we'll talk about the more peripheral radial muscles first. So the radial muscles in this case are much larger, and therefore that means that they're relaxed, whereas they are contracted in the case of dilatation. In the circular muscle, which is more central and surrounds the pupil, we can see that in this case, the muscles become fatter, and that's because there is contraction of the circular muscle in the case of the constricted pupil in high light, whereas in low light it is relaxed and therefore a bit thinner. So we can see that the inverse effect is carried out by the circular and radial muscles. So in response to low light, there will be dilatation of the pupil, mediated by a contracted radial muscle which pulls it taut and away, allowing the pupil to expand and dilate, and there is relaxation of the circular muscle which encircles the pupils, allowing it to grow to its fullest extent. So we have dilatation, contraction, and relaxation, and we can see that our answer must be option C.